Hello, welcome to this session of OpenMentor.net. We are seeing C programming. In this session, we are going to talk about global variables and local variables and their scope. If you look here, I have defined A equal to 10 over here. There are three procedures. One is P1, P2 and main. I have got A at the top of all. I have got another A in P2. I have got another A in main. So when main is being executed, wherever you are referring A, this instance of A is taken care. The moment it branches from main to P1, in P1 I have not declared A. So what it does is it automatically takes whatever is global. When I come back to main and I say P2, P2 has got its own snapshot of A or instance of A. Whenever I refer A, it is taken care over here. So let me execute this. A in main is 15, A in P1 is 10. P1 has not got a separate variable. It is taking the value of A from global. P2 has its own instance of A. So if you see, the values are different based on where you are accessing that variable A. The name is exactly the same. So this is global A, this is local A, this is local A. So as long as the program is getting executed, this A lives. Whereas the moment P2 is called, a separate instance of A is created. The moment you exit P2, this A is getting erased out of memory. The moment you go out of main, this is still living, but it will not get accessed. It will get accessed wherever there is a scope. For example, from main I branch to P2. It has its own local instance. It will not access the instance of main because the current scope is P2. When I say scope, whichever procedure or function that is currently being executed, that takes precedence. If it is not declared in that, then global takes precedence. This is called scope of the variable. When you say lifetime of variable, when P2 is being executed in memory, this has the lifetime. The moment the program exits out of P2, this variable is gone, history. When the program is executing, this is in memory, but when the program finishes, this goes out of the life. This is called the lifetime of variables. Now I'm going to show you another program. If you see here, there are two procedures, P1 and main. In main, I have got a variable called A equal to 15. I call P1. Inside P1, I'm passing this A and I'm incrementing this. Sorry, I have to increment P. Okay. As we discussed, this P has a scope within P1. It has a lifetime within P1. Now let me execute. I'm calling this P1 3 times with the same 15. Let us get executed. Now it says P is redeclared because the parameter name is also P and this is also P. Now let me say integer P1 as a parameter. Okay. Now printf P1, but I am accessing P here. Now let me do one thing. P equal to P1. I am just taking it. I am passing a parameter to this function. I am assigning to a local variable P. I am incrementing that local variable. Let us execute this. A is in main, that is having 15. I passed 15 to P1. 3 times I passed. No problem. It's all 15. Okay. Now look at this. Let me do something over here. I am printing this value here. I'm printing now the parameter which is getting initialized to local variable. Previously I showed you the same parameter I am passing again and again. As long as I don't change it over here, that doesn't change anything. which is very simple. Now I'm going to show something. I assign that parameter to this local variable, then I'm printing that local variable. Soon after the display, I am incrementing that local variable. Let us execute this. Again the same effect. Though I am incrementing p++, though 3 times I have called, it is not getting changed. Because by the lifetime of the variable, if you look at the lifetime of p, the moment p1 is called, a new birth happens to this p. It's a new instance. So it doesn't have anything in it. Okay. Now, the moment you are going out of this, then there's a problem. Now, let us do something. I'm going to say static int p. Now I'm going to do a magic. The moment you declare the word static, it is not going out of memory or getting erased. It has the full lifetime. Though you are exiting out of P1 procedure, it's not going to die. Let me show you a magic over here. Look at this. I slightly modified the program. I have static integer p equal to 10 I have declared. Now I am printing the value of p. So first time, what I expect here is 3 times I call, irrespective of my p1 parameter, which has no bearing on p. What I am expecting here is I call it 3 times, though I increment it 3 times. I expect it to have the same value 10, but it will not happen. Let me show you slightly different. I will remove the static and then show it to you. Then I will show you the difference. 3 times I call, the variable p is getting initialized to 10, no problem. Now I put the word static. Now I execute. Look here, p in p1 equal to 10. First time it is called. Second time when I got the call, it is 11. Third time when I call, it is showing 12. How come? Because I have been incrementing this p. For the very first time it gets initialized to 10. Okay, it doesn't die soon after the exit of this program or the exit of this particular procedure. The moment you use the word static, though the scope of this variable is within this procedure, the lifetime of the variable is as long as the program is running. If it's a local variable without the static keyword, it is getting initialized every time. But the moment you put the word static, it gets initialized for the first time. After that, before exiting the procedure, what was the value? It retains the value. On top of it, it keeps on incrementing. That is why, let me execute once again. First time call, it was 10. Second time call, it was 11. Third time call, it was 12, because it retains the last value of during that last execution. So static keyword introduces the total lifetime to that whole variable as long as the program is running. It's not this particular variable will not get erased when this procedure is exited. So this is the way that you can change the lifetime of a local variable. But you need to be very, very careful when you are using static variables, because unless you initialize proper, you may not have a good track of what was the value when you called it last time. So you need to be very, very careful on that. Thank you.